Hi everyone, myself Srushti. Let me introduce my team members Amulya BN, Fatima Armain, and Vaishnavi K. Reddy. We are here to present our project on a rule based classification system to predict disease based on symptoms. It explores how we can use simple rules to assist in early stage diagnosis, especially in areas where advanced healthcare systems are not easily accessible. Introduction. In medical science, early diagnosis often determines the success of treatment, but in many remote or underdeveloped regions, doctors may not have access to expensive diagnosis tools. We propose a rule based system that uses predefined rules to map combinations of symptoms to diseases. The kind of system is especially valuable because it's transparent, easy to use, and doesn't require large amount of historical data. And the next slide is problem statement. One of the major challenge in healthcare is symptom overlap. For example, symptoms like fever and fatigue appear in many illnesses. This often leads to misdiagnosis, especially when specialists or lab tests aren't available. We addresses this issue by developing a simple decision support system that relies on medical rules, a kind of virtual assistant to suggest possible disease based on what the patient is experiencing. And the next slide is objectives will be continued by Amulya.
So I'll be explaining about the objectives. So a project is to create a simple rule-based system that can predict diseases just by using symptoms given by the user. Firstly, it's easy to understand for everyone, even for the non-medical people. It understand need big data for or machine learning. Also, it's very lightweight, so we can use it even in remote places where internet or resources are limited. So the next slide is about methodology overview. So let me explain how our system works. First, we collect symptom disease information from trusted medical sources. Then we create if-then rules based on this. For example, if cough and the fever is predicted, then it predicts flu. So when user enters their symptoms, we compare with our rules. The system gives scores and finds the most likely disease. We test it using many different cases to make sure it works correctly or not. In the future, we can even connect it with a chatbot or user interface. The rule-based classification. The system uses simple logic. For example, if cough and fever is predicted, it means flu. It can also predict more than one disease, and we can easily update the rules when new medical info is available. The next slide will be continued by.
Here I'm explaining about the rule based classification, simple logic based structure. We are using a way more simple logic based structures, and it supports multiple diseases prediction and allows easily updating the rules while the medical knowledge evolves by years or an day by day. It enables the transparency in system decisions. Next slide. Here these are the use cases. We are using remote healthcare centers like with the limited staff. There is no much human work to do in production. Like we can easily use the machines to predict, and health boards providing 24 by 7, and emergency team classifies the patient cases. Like we can easily classify urgencies of an patient, like by their urgencies, and educational tools for training medical students. We can use educational tools for train the medical students. Next slide continued by Fatima.
Extremely transparent means anyone can see how the system arrived at a prediction. The next one is no training data means no need for storage and no risk of bias from old data sets. And third one is it runs on minimal resources, even basic smartphones. So the limitations are it's not flexible. If a new disease or variant appears, rules must be updated manually. And second one is it finds it hard to distinguish between diseases that have many shared symptoms like COVID-19 and flu. And the last limitation is as more rules are added, the system becomes harder to manage. So we arrived at conclusion. In conclusion, our rule-based system successfully offers a practical, low-cost, and reliable approach for early diagnosis in limited settings. It performs well for simple cases and offers a great foundation for hybrid models. In the future, this system could be extended with probabilistic logic, fuzzy matching, or AI integration, making it more powerful while still remaining interpretable. So these are the references. Thank you.